Bismillahirrahmanirrahim. Students, welcome to Bagh School Physics Department. We will continue with the past papers practice, and this is lecture number 8. And in lecture number 8, we are going to discuss next two MCQs. MCQ number 19. Two springs X and Y stretch elastically. The graphs show the variation with extension X of the force F applied to each spring. This is the graph for spring X, and this is the graph for spring Y. Question says, which statement is correct? Students, before opting for the correct option, let us try to understand and analyze the graphs for spring X and spring Y. For spring X, it has been shown that for an extension of 10 centimeter, 20 Newton force is required. And for spring Y, for an extension of 5 centimeter, 80 Newton force is required. So to standardize the two graphs, to make these graphs comparable, if we try to know the value of force at an extension of 5 centimeter, it will be 10. It means that for an extension of 5 centimeter, spring Y requires 80 Newton force, and spring X for an extension of 5 centimeter requires a force of 20 Newton. And another important point to remember in this question according to the graphs is that it is the area under force extension graph. It is the area under force extension graph, this part of the graph, which is equal to the elastic potential energy or energy stored in the springs X and Y. Now let us understand and discuss the options. Option A, when each spring is given the same extension, the energy stored in Y is 4 times the energy stored in X. No. When it is when spring X is given extension of 5 centimeter, the force required is 10. When it is given the same extension 5 centimeter, the force required is 80. It means the energy stored is 8 times in Y for the same extension, not 4 times. So option A is going to be incorrect. Option B, when each spring is given the same extension, the energy stored in Y is 8 times the energy stored in X. Yes. For the same extension, for example, for an extension of 5 centimeter, the force required will be 10 Newton, and for an extension of 5 centimeter, the force required is 80 Newton. So it means that the energy stored in Y is 8 times the energy stored in X for the same extension. This is seems to be correct and feasible option. But let us discuss the next options as well. Option C, when the same force is applied to each spring, the energy stored in Y is 4 times the energy stored in X. No, when same force is applied, this doesn't hold, that energy stored in Y is 4 times the energy stored in X. So option C is also incorrect. When the same force is applied to each spring, the energy stored in Y is 8 times the energy stored in X. This is incorrect because it is for the same extension that energy stored in Y is 8 times the energy stored in X, not for the same force applied. So we are left with option B. So option B resultantly is correct option. MCQ number 20. The diagram shows the force extension graph for a steel wire up to its breaking point. Okay, this is the limit of proportionality. This is a proportional graph up till this point, and then it moves on to the breaking point. Question says, what is the best estimate of the work done to break the wire? Students, to calculate the work done to break the wire, we need to calculate the area under extension graph, because we know that area under force extension graph, that is equal to elastic potential energy or strain energy stored in the spring or the elastic material. So if we want to calculate the work done to break the wire, we need to find the area under the graph, and this is equal to work done to break the wire. Students, this is the area under graph, this area under the graph, this is the area under graph which we are going to calculate. And to calculate this area, total area under the graph, we can divide this area into different figures. We can assume it this is a triangle. We will find the area of this triangle, then this rectangle, and then this triangle, and then we will sum the areas of these three figures, and the total area will be equal to the work done to break the wire. There is another way to calculate the work done area under the graph, that is this is a triangle and we can assume it as a trapezium, and for this we will apply the formula of trapezium, and after finding the area of trapezium we will add it with the area of this triangle, and the sum will be equal to the work done to break the wire. One thing here is very important, that extension is given in millimeter, while calculations this need to be converted into meters, otherwise you will get the wrong answer. So after applying the correct formula and correct values in SI units, you will be able to get the value work done to break the wire, that is 2.1 joule. So it means option A is correct. I hope these are clear to you. If you have any problem, you can contact me. Thank you. Allah Hafiz.